Okay, I'll share again. So the plan for today is just to solve the first part of problem set 4. So what I did was I solved number 1, number 2, and the first part, the short answer part of last year's exam. And then next week I'll solve the in-depth part, as well as I'll write some short essay to give you an example of what I'm looking for. So as I found works better, I actually prepared the solution yesterday. So I'll just talk you through it, and then I'll post this, of course, online. And at any time, feel free to stop me if there's something that is not clear or you don't understand. So starting off with the problem from the textbook, 7.12. It says, consider the model of section 7.8. Suppose, however, that monetary policy responds to current inflation and output, and then it's given by this equation here. So you'll recall that in the baseline DSGE model, the 3-equation DSGE model we had in chapter 7, it was all forward-looking. So the interest rate was set with the expectation of inflation in the next period, so pi t plus 1, then the expectation of output in the next period. So now we can make a different assumption. It's not going to be expectation. It's going to be what's the actual outcome today, okay, at time t. So then it says, then what are we supposed to do? For the case of white noise disturbances, find expressions analogous to in the textbook where they show what happens when you have white noise disturbances. And then what are the effects of an unfavorable inflation shock in this case? Right. So the first thing I did, and I think this is always good to do, is just to write down the 3 equations. So this one is directly from the problem. Okay. And then these 2 come out of the textbook. So these are the other 2 equations of the DSG model in the textbook. Okay. Here I wrote white noise, and then I missed something here. So there actually should be. It should say that the expectation of anything at time t plus 1 is equal to 0. This is sort of delogged. So we assume that this is all relative to trend. So when we have 0, that means that we're right on trend. So yeah, that's our assumption. So then we can now rewrite this equation and this equation without these expectation terms, because those are just 0 when the shocks are white noise. So then we get these 2 equations. And of course, this third equation, it doesn't change because there are no expectation terms here. So now we have 3 equations when we're talking about white noise. This top line here, stop with this thing. I have to delete the annotation or else it's going to stay on the screen. We have this top line here, and then we have these 2 equations. Okay. All right, so what's the question in the problem? It says, what happens when there's an unfavorable inflation shock? Okay, so I interpret that as meaning what happens to both inflation, output, and the interest rate when UT goes up, UT pi goes up. Okay. And, it's not as simple as it looks. Why is that? Because you can see, like, if you look at inflation here, well, you can see that if UT pi goes up, then inflation is going to go up. But there's also this YT term, and it's not clear exactly how UT going up is going to affect YT. Why is that? It's because if we go back, if we look at the equation for RT, you can see it includes both the pi t and the YT. So this UT is going to filter through the pi t into the RT, and then through the RT, it's going to affect YT, and then through the YT, it's going to affect pi t. So you've got this complicated system of equations where everything's affecting everything else. All right, so how are we going to solve this problem? How are we going to figure out what happens when UT goes up, when we have this complicated system? All right, well, what we want to do is we want to get everything exogenous on one side of these equations. Okay, so we want to have one side where there's no YTs, RTs, or pi t's. We want only to have the shocks. Those are exogenous. So how are we going to do that? Well, it's going to take a little bit of algebra. So let's look first here at these two equations. Well, you can see that in this pi t equation for pi t, we have a yt. So we can substitute that out. Okay, so we can just, you can see all I'm doing is taking kappa and then multiplying it by the definition of yt here. Okay, so we're going to get this equation. So all we've done is we've just substituted out the yt by inserting rt and ut. Okay, so now we have pi t in terms of rt and then two exogenous things. Okay, next, what are we going to do? Well, we're going to go down to our equation for RT. So I scroll up now. Sorry about the scrolling. Thing's a little big. Maybe I can make it a little smaller just for a second so I can refer to these at the same time. So here we have pi t in terms of RT and exogenous things. Up here, I've got RT in terms of pi t, yt, and exogenous things. So what am I going to do? I'm going to take my definition of pi t here, and I'm going to substitute it in for this pi t. I'm going to take my definition of yt, which depends only on RT and exogenous things, substitute that in up here. Okay, so I'm going to make these two substitutions, and then I get this equation. So you can see that I've got RT is equal to phi pi times my definition here of pi t. So I've inserted that here. And then I've got minus phi y times my definition of yt here. It's minus because there's a minus here. So that's these two terms. And then finally, I have this utmp here at the end. Okay, now things are looking pretty good for us. Why is that? It's because, look, I've got only u's here. So those are exogenous shocks, and then RTs, which are the endogenous things. So all I have to do is get the RT on one side and get the exogenous things on the other side, and then I'm done, with RT at least. So you do a little bit of algebraic manipulation. You put all the RTs on one side. You divide through by the thing that multiplies RT. And then you end up with this equation, which is RT is equal to 1 divided by this thing times everything on this right-hand side. And I didn't write it all out, but that's what it is. Okay. And then I kind of stopped there. Okay, so now remember, what's the question? The question says, how does RT change when there's an unfavorable inflation shock? Okay, so putting that into calculus notation, that says, what is the partial derivative of RT with respect to ut pi? In this case, I think the partials and the totals would be the same. But in any case, we can do that by looking in here. Okay, so when ut pi goes up, that's down here, we're going to have a phi pi times 1 divided by this thing here. So that's just what I've written. Okay, and then this term drops out. Why is that? Because there's no ut pi there. This term drops out because there's no ut pi there. Okay, so we end up with this expression. And what can you learn from this? We assume that all of these phi's are positive. We assume everything in here is positive. So it says that when inflation is shocked positively, if you like, that causes the interest rate to go up. Okay. After considering all of these circular effects. All right, so then let's look at the effect of the effect of this inflation shock on yt. All right, so if I kind of look at the definition of yt, you can see it's got an RT in it and then a UTIS in it. So the partial derivative of yt with respect to ut pi is just going to be negative 1 divided by theta times the partial derivative of RT with respect to ut pi. And why is that? Why don't I have to worry about this term? Well, this thing is independent of ut pi. It's an exogenous shock. Okay, so now I've written that. It's negative 1 divided by theta times this partial derivative, which we already have from here. So let's just plug in the definition. And then we get this, which is nothing other than just rewriting this expression here multiplied by negative 1 divided by theta. What can we learn? Well, since everything, all the sort of parameters here are positive, you can see we have a negative sign out front. This says that when there's an unfavorable inflation shock, it causes output to fall. Okay. Finally, what's the effect of the inflation shock on inflation? Okay, well, we have two terms. If we look up here at the definition of inflation, you can see we've got a yt, and then we've got a ut pi. Well, of course, the derivative of ut pi with respect to ut pi is 1. And then here we have the derivative of output with respect to ut pi. We know what that is. That's this expression right here. So, basically just plugging those things into the definition of, into this derivative, I should say, we get the 1 for the ut pi, and then we get this one for the derivative. Well, we get kappa times the derivative of y with respect to ut pi is this. Plug everything in, do a little bit of calculation, and we end up with this thing over here, which says that the derivative of inflation with respect to a unfavorable inflation shock is this thing, which you can see is positive. It's greater than 0. And that's about all there is to say about that, I think. Yeah, I think that's all there is to say about that. So that's it for question 1 of the problem set. Any questions?
If we forget the 1, I guess we're in deep trouble, right?
If we forget the 1, we're in deep trouble. Yeah. Well, then it would be negative. That's right. So you would incorrectly think that if there was a positive inflation shock, it would have a negative effect on inflation. I mean, it is sort of interesting that when there's a positive inflation shock, since it's going to cause YT to go down, I was actually just trying to think if I could sign that, if I could prove that thing that I just showed you is between 0 and 1. In fact, maybe you can. Yeah, you can. Of course you can. So, suppose that there was no effect of the inflation shock on output, right? Well, then this derivative would be 1, which is what you'd expect. But we know from our previous derivative here that the effect on output is negative, right? So it's going to moderate the effect of the positive inflation shock on inflation, because output has sort of a negative effect on inflation. So since that's true, you can see that this thing that we find here at the end is a number between 0 and 1. It's not as large as it would be if output were exogenous. So yeah, that's kind of interesting. So that's a good point. Sounds like you unmuted.
Yeah. What if there is a favorable inflation shock? I mean, does it make a difference between unfavorable and favorable?
I mean, no, right? I mean, you'd want to, so we're taking here the derivative with respect to ut pi going up. So, the derivative with respect to ut pi going down would be the negative of these things. So there's no difference in the size, but there's a difference in sign.
Okay, so, thank you.
Sure. Any other questions? Right, if not, then let's look at the next problems, which I now realize I'm gonna have to pull up my slides. But the next problem is just to do the 2 problems from my slides, which is 6 puzzles 1. Let's grab those slides. Puzzles 1. Right, so I think I said the first one is on slide 14. Okay, so as you recall, part of this, the way that we're going to explain home bias in the 6 puzzles is we're going to say that that there are trade costs. Okay, so why do you trade, or why do you consume more of the good that you're endowed with at home? It's rather than the good that foreign is endowed with. Even if you sort of like the 2 goods the same amount, you're going to consume more of the home good because there's shipping costs to get the good from foreign to come to home. So that makes it more expensive. Okay, that's more or less the intuition. And what I wanted to show with this problem is that there's an alternative explanation. And actually it's part of the trade literature. It's called, Oh my gosh, I can't remember the name for it now. I honestly can't remember the name, but it's the idea that suppose that I'm going to make something that, suppose that I'm going to make bicycles. Okay. Do I want to make my production? Where should I put my factory? I'm going to export all over the world and say there's very small trade costs. Where do I want to put my bicycles? Even if there's small trade costs, the place I want to put them, all else equal, right, is close to where the demand for bicycles is. Okay, so in a sense, there's an interplay between trade costs and then just preferences. Okay, so what do I mean by bicycles? You probably wouldn't want to put production in the United States, where people don't ride bicycles as much as they do in some cities in Europe or something like that. Or maybe you want to put them in, a place like Denmark that's very flat, or Netherlands, rather than a place that's very mountainous, like, I don't know, Switzerland, because the Swiss aren't going to consume that many bicycles. So the idea here is to show that without trade costs, if we rather just use preferences, then we can actually get very similar results to trade costs. Okay, so that's it. So it says, what if people prefer the goods that are produced in their own country or their own endowment good in terms of the language of the problem? Okay, so we're going to suppose that there are no trade costs and we have preferences where omega is less than 1. So this says that the home country prefers the home good, right? Omega is less than 1. So all else equal, if the prices are exactly the same, then the home country is still going to consume more of good H rather than good F, simply because they prefer it. They sort of have a weight less than 1 on the foreign good. Okay. So I say here derive demand and show that omega functions similarly to trade costs when the countries are symmetric. Okay. So, oops, not here. Here. Okay, so excuse my scribbly handwriting, but I just wrote down the household's optimization problem from home, or the representative consumers optimization problem. So they want to maximize their utility. This is for home, of course. Maximize the utility subject to the budget constraint, which says the total amount of money that the home consumers have is if they sold their entire endowment, and that has to be equal or greater than or equal to the price of the home goods they consume plus the price of the foreign goods they consume. And of course, these P's, they don't have any stars on them because we're referring to home prices. Okay. Now, if you solve this, so now there's a lot of stuff going on here. I'll just very briefly say how I solved it, but I think the easiest way to solve this sort of problem is to say isolate CH. So, this budget constraint implies a relationship between CH and CF, the things we want to optimize, and it's given by this equation here. And then we can just plug in this definition into the optimization problem. Okay, and then we've eliminated one of the arguments we have to optimize. So you can see now, instead of maximizing both CF and CH, once I've plugged in this definition of CH, I only have to maximize utility with respect to one argument, CF, and that's easier, right? No need for Lagrangian anything. So, so what I do here is then I take the derivative with respect to CF of this utility function and set it equal to 0. Okay, so that's what I've done here. And then these two things cancel each other out. Theta minus 1 divided by theta is going to cancel with theta divided by theta minus 1. And then this expression over here, this is something greater than 0. So we can divide both sides by this thing and eliminate it. Okay, so what we're left with is just this thing here, which has a negative sign on it, and this thing here, which is CF to the power negative 1 divided by theta. Okay, so I just move this thing to the other side and get rid of the negative sign, and then I end up with this expression. Okay, so doing a little more manipulation, you can end up with CF. Okay, so here's the optimal level of consumption of the foreign good. It's the home endowment times this term here. Okay. Now, from the definition, or here's the budget constraint again. If I know CF, then I can also get CH. So I can plug in my new, my optimized level of CF into this budget constraint. With a little more algebra, I'm going to end up with this thing here. Okay. Now, finally, I'm going to make an argument from symmetry. Since the home country and the foreign country are exactly the same in equilibrium, the cost and the endowments are exactly the same, I should say. That's important too. The prices are going to be the same too. Since everything is the same in the two countries, once they start to trade, the prices are all going to equalize as well, simply because whatever decision one country makes, the other will make it as well. So that's that. So if we do that, then we can plug in ones for these things. Everything goes away except for the omega. Okay, so we get, for CH, we get 1 divided by omega to the power theta, divided by 1 plus 1 divided by omega to the power theta. We can simplify that by multiplying the numerator and the denominator by omega to the power theta. So that's what I do. And we end up with this expression. We can do something similar with CF. If you look up here, this thing becomes 1. This becomes 1 divided by omega to the power theta. Again, do our manipulation. And before I say anything more, note that this result makes sense because you'll notice that I feel like I've done something, I've dropped something here. This actually should have a YH in it. And this should also have a YH. So there should actually be a YH here. Okay, this one is more important, so I'll correct this before I post it. But there should be a YH here. There should be a YH here. Let's note that so I remember to correct it before I post this after class. It's YH. But anyway, this makes sense now that I've added this by H. Why is that? Because check it out. If I add, okay, so we've assumed that PF is equal to PH. We might as well just call them 1. So then if I add 1 divided by 1 plus omega theta, and then down here I add omega theta plus divided by 1 plus omega theta, those things are going to just be 1, and then it's going to end up being my endowment. Okay. So anyway, that's that. That kind of makes sense. And then we're going to divide CH by CF, and we're going to end up with 1 divided by omega to the power theta. That's what I have here. And that's kind of the end of the problem. Why is that? Because if I look at the slides, let me get rid of this thing. If I look at the slides, then we this is the big expression here, that CH divided by CF, of course, now we've assumed that PH and PF are the same. So CH divided by CF is equal to 1 divided by 1 minus tau to the power theta minus 1. Now check out my expression in the solutions. We've got 1 divided by omega to the power theta, and omega is some number that's less than 1. 1 minus tau is some number that's less than 1. So, this analogy is fairly tight here. So that's that. Okay. Questions? Yeah, so the idea is just that this omega functions very closely to a trade cost. So preferences are very similar to trade costs. Okay, if there's no questions, then move on to the second problem from the slides, which is this exercise. So this one is actually pretty simple. So you'll recall that the second part of the slides is about the Heroica-Feldstein puzzle, which is that national savings and investment in a country are correlated, whereas you might expect that wouldn't be true, since capital is mobile across countries, and you'd expect investors to seek the highest returns regardless of where they are. There's no reason that if one country is saving a lot, that they should also have relatively high investments in their country. You might think those things should be uncorrelated, but they're not in the data. And the solution that Rogoff and his co-author that I'm forgetting at the moment come up with is that because of the way that trade flows work, when a country wants to borrow, then it faces a high real interest rate. And when it wants to lend, it faces a low real interest rate. And the idea is that when you're borrowing, then you're sending, then you're sort of importing more than you're exporting. So you're you're a net importer. When you're saving, then you're a net exporter. And because of the way that trade costs work, it kind of pushes prices in the wrong direction for you, basically. Okay, so what this question says is, it says, let's take a concrete example. So let's put some actual numbers in in the equations that we derived in the slides. And then what are the actual values that these equations take, that this real interest rate takes. So before we look at the actual numbers, let me remind you about our solutions here. So R here is the real interest rate, and then R star is the sort of international interest rate, the one that you'd face in other countries. Okay, so the question is, what does my real interest rate look like? Yeah, R star here would be like the nominal interest rate you can access in foreign countries. Okay, so we get an equation from the theory that we developed in the slides. Not going to go through the whole thing now, but it looks like this. So basically, you're going to get 1 plus R star, so the nominal interest rate you face abroad, and then you're going to multiply it by this big term with the important thing that P star H, the price of the foreign good in the home country, is going to be divided by 1 minus tau in the numerator, and then multiplied by 1 minus tau in the denominator. Okay, so let's look at our actual values. Now I'll flip to my solutions. Okay, so I've just repeated what was in the problem there. So R star is 0.05. You can access a 5% interest rate abroad. Tau is 0.1, so the iceberg trade cost is 0.1. If you ship 100 units of something abroad, only 90 of them arrive. Okay. Theta is equal to 6, which implies a markup. So this is the elasticity of substitution between goods. So it implies a markup of 20%. That's all that you need to know about that. You don't need to know that. And then finally, we've assumed that the prices abroad are just 1, just to keep things simple. Okay. So so here I've very sloppily copied the equation from the slide I just showed you, and then plugged in the numbers. Okay, so you can see replace R star with 0.05. PH star is 1 divided by 1 minus tau. Well, that's 0.9 to the power 1 minus theta. Well, 1 minus 6 is -5, plus 1 to any power is still 1. So plus 1 to the power, again, 1 minus theta is -5. So 1 divided by -5. Okay. Same thing in the denominator. Do that calculation on a calculator. That's what I did. And you end up with 1.17. So in other words, R is equal to 0.17. Okay. So recall that the nominal interest rate you can access abroad is 0.05. Here, when I'm a lender, then the real interest rate I'm facing is 0.17. So when I want to borrow, okay, I just said lender. When I'm a borrower, then when I want to borrow, then I'm facing an interest rate that's higher than the nominal interest rate abroad. Okay, so that's the point. Now, suppose that I were a lender. That means that I'm exporting more than I'm importing. I'm a net exporter. Then what does my real interest rate look like? Well, we can just use the equation from the subsequent slides. So you can see that here I've got the equation for the lending case. So now I'm going to use this thing. The only difference is that here the 1 minus tau is multiplied in the numerator, and we're dividing by it in the denominator. Okay, so now I use that version. And here I'm just skipping a step and just immediately jumping to the part where I plug in the numbers. And you can see the only difference is that the denominator is now the numerator is the denominator. So you won't be surprised that that means that we get a number that's less than 1, 0.95. So it implies that the actual real interest rate when a country is a lender is less than 0. It means that the country is actually, well, you guys are living in Europe in 2021. You know what a negative interest rate is. So yeah, exactly. So this is lower than positive 0.05. So when I want to lend, I'm facing a low interest rate, real interest rate. When I want to borrow, I'm facing a high real interest rate. Okay, so that sort of explains, or that shows how trade costs can explain the home bias in investments, or the Feldstein-Heroica puzzle that people seem to invest in their own country. Okay, so yeah, that's it for the problem. Any questions? This one's kind of a plug and chug. Okay. And the last thing I want to do before I open this up to questions generally about the course from you guys is I want to answer the first part of last year's final exam. So the first thing I guess I'll maybe just mention, since we're looking at an exam, is this little opening paragraph, which my exams always have the same structure. So it says, please show your work and answer each question completely. Okay, so, in terms of the short answers, try to write a full sentence as an answer, just so I can be sure I understand what you mean by your answer. Don't just write no or something. Try to put it in a full sentence. I'll tell you the number of pages. I'm just going to edit this little paragraph. And then finally, and this one's important, just to avoid a lot of back and forth, which is difficult sometimes, in the way that CBS exams work. If you find that a question is unclear, like you don't know, like you're not 100% sure what I meant by something, just make your best guess and write out your assumption. You say, by whatever, I assume that you mean this, and then solve it if anything isn't clear. Hopefully that won't happen, but just in case it does, that will help. So yeah. Okay. So jumping into the answers. Now I know that the way I did these, I didn't rewrite the question because I was handwriting it. It would have taken a long time. So it says, in the Romer growth model's market equilibrium, is there too little innovation, exactly the socially optimal amount, or too much innovation? So you may note that the answer is too little innovation, as inventors don't internalize the benefit of innovations to future inventors. Right? And then just to say one more thing, since I'm talking to you guys, the idea would be that, when you invent something, in the Romer model, it decreases the cost of inventing the next thing, right? But as an inventor, you don't internalize that benefit. Like you don't benefit from, there's no way that future inventors can pay you for that. So, or you can exclude them from using your technology as a stepping stone to the next technology. Okay, and then what's that supposed to represent? It's supposed to represent the fact that if you think about patent systems, one important part of the patent is that it's public. So anybody can look up the details of an invention if it's a patent. Okay, and in fact, you'll see that some companies choose not to patent things because they don't want the secret to be released. Okay, so anyway. In the Romer model, because of that public nature of the patents, it means that there's too little innovation relative to the social optimum, because the inventors don't have any way of internalizing that extra benefit that they give to future inventors. Okay. Stop me if you have a question, otherwise I'm just going to kind of go through these.
Yeah, is internalizing the benefits the same as the idea is not being partially excludable?
Yeah, I want to be careful. I want to be a little bit careful, because in a sense, the ideas are excludable because the government makes them excludable with the patent system, right? I mean, the government says, here's a new idea, you can use it to produce, but only if you have a patent. You know, that's, so I mean, I want to be a little bit careful. Yeah, so what you said is partially excludable. I think that's the right way to say it. They're partially excludable. The government can exclude people from using them to produce, but they can't exclude people from using them to invent new things. So yeah, actually, now that I've rambled about it, I actually agree with you. Yes, they're partially excludable, partially. Okay, any other questions about that one? All right, second one. In the growth models we studied in class, what does the golden rule level of physical capital per unit of human capital maximize on the steady state growth path? All right, so there's a lot of words in there because I wanted to be precise, but the answer I wrote here is that the golden rule level of capital maximizes consumption. I guess I could have said on the steady state growth path.
Or in the future, because it doesn't maximize consumption today.
Yeah, that's right. It's on the important part is that it's on this, like at the steady state, right? So I mean, even if today you're gonna suppose that we're to the left of the golden rule level of capital, then if we start saving more, then today we're going to consume less. But today we're not in the steady state, right? So it's only in the steady state that the consumption is higher. So I agree with that. You know, alternatively, suppose that we just stop saving anything at all. Well, today our consumption is going to be super high, but the only steady state will be zero consumption. Any other questions about that one? Okay, number 3, describe the situation ruled out by the no Ponzi condition in the Ramsey growth model. All right, so I found it a bit difficult to summarize this in a sentence, but here it goes. Borrow to pay off debt and fund consumption forever. So what's it excluding? That people just borrow every period to pay off their debts and then keep borrowing more to fund their consumption. And then tomorrow when their debts come due, then they just borrow more to pay off their debt and then borrow even more than that to fund their consumption, et cetera, forever. You know, that's not allowed. Eventually you have to pay back everything you borrow. That's what it rules out. All right, number 4, why do we include a labor supply decision in the RBC model, but not in the Ramsey growth model? All right, so I write, unemployment is an important part of the business cycle, and to study it, we must include a labor supply decision in the model. Okay, so implicitly, unemployment isn't an important part of growth. That's not what we're focusing on. So we don't need to include it. It would just make the model more complicated without adding any insight. All right, you can see already on my answer to the next one. In the perfect foresight dynamic growth models we studied, does an increase in the rate of return imply an increase in the ratio of consumption in period t+1 to consumption in period t? Now, I wrote this with an exclamation mark because this is one that a lot of people got wrong last year on the final. So I think people were thinking about income versus substitution effects. So what that says is that we don't know what happens to consumption today if we raise the interest rate. Okay, it could be that consumption today goes up. It could be that consumption today goes down. It depends upon income versus substitution effects. If I'm a borrower, or say I'm a saver, and the interest rate goes up, maybe what I'll do, I mean, it makes it more attractive to save, okay? But it also makes me richer. So if I'm richer, maybe I want to consume more in both periods. That's the income effect. Or maybe I want to save even more and move more consumption to the next period. So it actually could have either effect on consumption today. An increasing interest rate could cause consumption today to go up, or it can cause consumption today to go down, and it depends on the parameters in the utility function and the consumer's problem. Okay, but that's not the question I asked. The question I asked was, does increasing the interest rate lead to an increase in the ratio of consumption tomorrow to consumption today? And that one, it turns out, does have a clear answer. And the answer is yes. So here I've written out a bit of math to show how that works. So suppose that the utility function is this one that we've been working with mostly in this class. This is the CRRA utility function. Okay, well, then the marginal utility looks like that. Okay. Standard Euler equation looks something like this. So it's marginal utility from consumption today has to equal marginal utility of consumption tomorrow, mediated by the amount that I care less about my future self, and then also the returns to saving. Okay, so let's plug in our little utility function here, and you can rewrite this equation to look like this. So the ratio of consumption tomorrow to consumption today is equal to beta times 1 plus r to some positive power. Okay, so clearly the derivative of this thing with respect to r is a positive number, right? If r goes up, then this ratio goes up. So yeah, that was a tricky one. That was the one that separated the 10s and the 12s. That was a good thing.
If we say anything about substitute or income effect, we're just wrong here, right?
It's barking up the wrong tree. I mean, I wouldn't say you're wrong because you mentioned it, but you know, that would lead you to think that the answer is, I don't know, it's indeterminate. And that's not the right answer. Okay. Number 6, why do firms increase production when the government prints money in the Lucas imperfect information model? All right, so the firms aren't sure if it's a firm-specific demand shock or a money shock, so they hedge by producing a bit more, right? They're tricked, right? They don't really know when they see that their product is selling really well, they're not really sure whether it's because people just suddenly start liking their product more, or if it's because the government printed money and now everybody's just spending more money. So to hedge their uncertainty, they start producing a little bit more. All right, number 7, what is the Feldstein-Heroica puzzle and why is it puzzling? What did I write? Okay, good, I wrote both. Okay, so actually I already said this just a few minutes ago, but Feldstein-Heroica is that savings and investment are correlated at the national level. Why is that puzzling? It's puzzling because intuitively, investors should seek the highest return regardless of their location. You know, if the return is really high in Bangladesh this year, everybody in the world should invest in Bangladesh since capital is freely mobile. Okay, and you know, there's no reason for Danes to invest in Denmark or whatever, Brits to invest in Britain. In fact, you might almost say the opposite should be true, since my income is in Denmark. Why would I invest in Denmark? That's like making my rate of return on my savings correlated with my income risk. It doesn't make sense. Okay. In the DSG model we studied, there's no capital accumulation, right? I don't know if we noticed that, but there's no capital accumulation that ties periods to each other. Why does it take time after a shock for the market to return to its steady state? Now I'm contrasting this with like the RBC model, where you do have capital accumulation. So then sort of naturally, if I build up capital to take advantage of a productivity shock, when that productivity shock ends, it's going to take time for me to reduce my capital back down to the steady state level. Okay. In the DSG model, there is no capital accumulation. There's nothing that ties one period to the next. How is it that we can explain persistence in that model? And right is in the DSG model, shocks are generically correlated over time. So there's persistence, right? So the shocks follow like an AR1 process, so that the shock today is related to the shock yesterday, and then plus some random innovation. So that's going to cause persistence over time. All right, there's two more. In our discussion of the menu cost model, we showed that if an individual firm does not change its price when no other firm changes its price, then there's a Nash equilibrium in which no firm changes its price. Does this argument also show that there are no other Nash equilibria? Briefly explain your answer. So you may recall from one of the problem sets, we actually found several equilibria in this model. So you can already guess the answer is going to be no. But no that argument, no, it does not. Consider that if all other firms change their price, an individual firm might find it optimal to change price. That would be another Nash equilibrium, right? So if no firms change their price, I might find it optimal not to change my price. That could be one Nash equilibrium. And then if every firm changed its price, then I might find it optimal to change my price, in which case that's another Nash equilibrium. So there's nothing stopping us from having more than one or many Nash equilibria in these models. All right, last question. Suppose that there's a single woman stranded on an uninhabited island. Obviously, she can't buy stocks or bonds. Is it possible for her to invest in the macroeconomic sense? Briefly explain your answer. I think that this is one that we even used in maybe the first class or the first couple of classes. So yes, by using her labor to, for example, make a fishing net, this takes away from her consumption the day she makes it, but increases later consumption, right? Which is a way of saving. You take away consumption from today, and then you get more consumption tomorrow. Okay, so that's saving in the macroeconomic sense. So even though there's no stocks or bonds, she can't do financial investment. She can make investments in a macroeconomic sense. All right, so that's all I have for today. Next time I'll solve these in-depth problems and then write out a little short essay. But that's all I've got. So are there any questions about the problem set that I've done so far today? Okay, if not, then let's take a break. Let's take a 10-minute break, and then I'll come back, and then I'll answer any other questions you guys have about course material. I'll take that after the break. All right, so I think that I am going to first field a question that I only saw on Zoom after I had already put you guys on break. Let's see, what's the right thing to put on here? So, I don't get my, I think I had you looking at the wrong screen. Let's try that again. All right. So there was a question about number 5 here on the question, and I think it was about intuition. Am I right? Let's see here. Intuition, yeah, okay. So what's intuition? That an increase in the rate of return implies an increase in the ratio of consumption in t+1 to consumption period t. Well, I think the way you want to think about this is that an increase in the rate of return is like a decrease in the price of the consumption good at t+1. So think about it. Think about the goods in different times, or the consumption in different times. It's just any two goods, apples and bananas. So if the price of bananas goes down, then we expect that the number of bananas relative to the number of apples consumed goes up. Now, you might say, why doesn't that also imply that the number of apples consumed goes down and the number of bananas consumed goes up, right? That's like saying, does consumption in period 1 go up or down, right? And the reason why is because you have to imagine that these people are actually already holding on to apples and bananas. So if the price of bananas goes down relative to apples, then that can make them richer or poorer. And then that might determine sort of the level of consumption of both goods. Yeah, so I think that's it. I think that all you can say is that the relative price of consumption in t+1 went down relative to consumption in time t. So therefore, the amount of consumption in t+1 relative to the amount of consumption period t is going to go up. So it's that price intuition, I think, is the right one. It's price intuition. Okay. So let me open it up to questions from anybody about anything in the course. I know that we emailed a bit before class with some of you. So
I have several questions.
Sure.
May I share my screen so that they are about problems and other things?
Yeah, go ahead.
Can you see it?
Yes.
So about the first problem on solo, this is the problem that I have understood the least. So here there are new assumptions in these problems, and I would like to ask how this affects the solo model. So what are the consequences of these assumptions? We have to assume that all labor income is consumed and all other income is saved, and that factors are paid their marginal product.
All right. Well,
So
factors are paid their marginal product. I don't think that's. Oh yeah. Because in the solo growth model, there's no decisions. There's just a savings rate. So I mean, basically what we're doing here is we're saying that the savings rate is going to change as the economy sort of gets closer or far, closer to a steady state, then the savings rate is going to adjust itself. Like in the version that we looked at, the simple version in class, the savings rate was fixed. Here it's going to depend because, if there's more capital, that's going to decrease the rate of return on capital, all else equal. So that's going to cause the savings rate to go down, right? So it's allowing there to be a variable savings rate as the economy grows. Did you want me to say more than that, Marco?
No.
Okay.
And what do the authors want to show in the end? Why do they do?
in that problem about the solar growth model. So they're trying to get back at, they're trying to refute in a simple way this argument from Piketty. So Piketty wrote this famous book, Capital in the 21st Century, where I think, I haven't read it, it's a very long book, maybe I should at some point, but I've also heard that it's not only is it long, but it's somewhat repetitive. So I haven't been able to convince myself to actually jump in and read it. I've only read summaries of it by other people. But I think that the argument that Piketty is supposed to make here is that the rate of return is higher on capital investments, is higher than the growth rate of the economy. So if that's true, then that seems like it would say that if, like, say, richer people have a higher share of their income from investments, then that's going to that gap is going to grow. So the richest are going to get even richer, and the people that don't have so many investments, most of their income is labor income. They're going to get, poorer and poorer relative to the richest people. So what the authors are trying to say here is, well, you have to remember that the rate of return is not something that comes from nowhere. It's something that's related to the amount of capital in the economy. So if the amount of capital in the economy is huge, because these rich people are saving so much, then it means that the rate of return on capital is going to fall. And in fact, again, I'm not an expert on Piketty's arguments here, and I should be a little bit careful in what I say, or take it with a grain of salt. But certainly what people are complaining about these days is a savings glut, where there's so much money invested that the rates of return, interest rates, are extremely low. So here it's hard to argue that R is greater than G, that the rate of return on capital investments is higher than the growth rate in the real world. But that's not related to the problem. The problem says that those objects are endogenous. So it's, Piketty's argument doesn't work, basically.
Okay. Then to question B, you drew this graph,
right?
But usually we have also the line of the investment, and the steady state is where the investment line intersects this the break-even investment line. Why in this case we don't have the investment line, so this line?
Yeah, that's right. So so that picture that I drew there in B is about finding the golden rule level of investment. Okay, so how do we want to think about that? That's going to be the difference between the total amount that's produced. How do we find that? We want to find the place where consumption is maximized. Where is consumption maximized? Well, consumption is the difference between output and investment. You agree with that, right? I mean, it's whatever people don't invest, right? So what I'm plotting here, so you recall that line in steady state, the line with slope n plus g plus delta, in steady state, that thing is equal to investment, right? S times F equals n plus g plus delta.
Yeah.
Okay. So what I want to do is I want to find the place where the gap between output, F of little k, and that line there with slope n plus g plus delta, where the difference between those two things is maximized. That's going to be the spot where consumption is maximized in a steady state.
Okay. So you want to find the golden rule level.
Right. Yeah, I don't know why I put a dot there. Something there looks weird because I put a dot where the two lines cross.
You said that this is the steady state when you put the dot.
Yeah, well, that shouldn't be right, because then there should be an S multiplied by F of k, if that's what I said.
You said that if we are to the left, then we are going to this point, and if we are to the right, then we are approaching this point as well.
Okay. Well, then there should be an S there. Then I dropped an S in that answer, which should be S times F of k. Unless the savings rate is 1. Okay, then there's another question there that I can see you're confused about one little thing. So then you said, if you scroll up a little bit.
Yes.
So you wrote here, why is it that when f prime of little k is greater than n plus g plus k, the economy is left of the steady state? Okay, so the point here is that when f prime of little k is greater, that means that little k is smaller, right? Because the slope of the production function is falling in little k. So when f prime of little k, when the slope of the production function is too high, if you like, then that means that little k is too far to the left.
Okay. Now about the Ramsey problem. Here, yes, in this problem, the book writes that the tax is rebated to households, so the locus with the point where the motion of capital is equal to 0 is unaffected.
Okay.
And what happens if the tax is not rebated?
What do you want to do with it?
I don't know, but
Destroy it? Let's
is it
destroy it.
possible that it is not rebated?
Sure. I mean, you can do anything. The government can take it and throw it into the ocean if they want. You want to have them do that? I mean, it depends, right? So I mean, okay, what are they doing here? They're gonna create this tax and then they're gonna rebate it to consumers. So imagine if we have like imagine if we had a tax on cigarettes, okay? And you know, suppose the government were to take the funds they generated from their cigarette tax. Okay, you know, of course, there's tax on cigarettes. People are gonna buy less cigarettes. It's more expensive, of course. So now suppose the government takes that money and just destroys it. You know, that money is a weird thing, but yeah, let's say they take the money and destroy it. Well, now it means that the people that would have bought cigarettes are poorer and everybody else is kind of the same, I guess. You know, it's a bit complicated. There's maybe more effects than that, of course. But now suppose that the government is going to rebate that cigarette tax. They're going to give it back evenly to everyone. Well, then sort of in aggregate, you know, the economy isn't, nobody's like, you know, in aggregate, nobody's poorer. But there's going to be a shift from people that bought cigarettes to people that didn't buy cigarettes. So yeah, I mean, so what the government does with the revenues is going to change something like, say, this equation you have there. So suppose that the government destroys the capital that it taxes. If it does that, then of course, in the capital, in this equation for the law of motion of capital, you have to take away the part that the government destroys. So then there's going to be an additional term there. But I mean, you just have to make an assumption about what the government does with the capital, and then whatever that'll, you know, work its way through the model somehow.
Okay. Then about the budget constraint in the RBC model. So in the mock exam, we had also this budget constraint that we had to rewrite in order to plug it in the utility function in place of C.
Okay.
And in class, we did not consider this A. So there is no growth rate of productivity in class.
Okay.
But in the mock exam, we have also A. So
okay.
Why is there this difference? Do we have to consider A or not when we rewrite this budget constraint?
I mean, I have to take a look at the problems, but what did we assume in the, so is there growth of A in both models?
Yeah, in both.
There's growth of A. So why do we write it differently in the two?
Yeah, exactly. Why?
Consumption per person, capital. All right. Okay, wait. Now let's look at this resource constraint written in class. Hard for me to immediately recall why we want to do that differently. Must have something to do with what we're assuming about the growth of A. We can certainly look at the question from class and then also the one from the mock exam.
Should
So you can
stop sharing this?
Yeah, you can stop sharing. You can stop sharing if you want. So let's look at the question from class. Here, I'll start sharing. All right. Right. So the only real difference is that this one is discrete time, whereas the other one is continuous time. Okay, well, here, check this out. So we definitely get this equation, that the wage here is and here we got also something that looks very similar to what I have in the other thing. That means wait a second now. Is there a labor choice here too? Yeah, there is a labor choice. So I guess it's going to depend on like a steady state. We want it to be, the reason why we define those the way we define them is because we want to define a steady state relative to those concepts, right? So we want to find something that doesn't change in steady state. Yeah, it's going to be hard for me to do because I haven't, I'd have to go back and over and look at the solution that I did to the mock exam.
You write the equation in the mock exam.
Sure. You're saying down here, I did it. This one, huh?
Oh, down. This is the budget constraint.
Mm-hmm. I mean, it looks fine. That looks fine. Yeah, so I mean, I guess what I can say is generally in these models, the reason that it's convenient to define little kt in some way, say whether that would be little k divided by, or big K divided by n, or big K divided by a times L, I guess, is because you want to define a steady state relative to those things, right? So I want to find something that's going to be constant in steady state. Your question is, why is it different? Why would I want to do that differently in the one from class versus the one in the mock exam? That is difficult for me to answer right now without thinking about this problem, which I haven't thought about for a year. In principle, it shouldn't matter. It's just that, like, if you can define your variables however you want, but somehow the answer should be cleaner with one relative to the other. So again, if you have steady state defined relative to something that doesn't change, that's going to be easier for you to talk about a steady state. Specifically, yeah, I'll have to take a look at it and get back to you about it, about why exactly that's different here. Again, the only difference is that it's discrete time versus continuous time, so it's got to be something related there. Also, the setup might be slightly different. I don't know.
Okay. I have some other questions.
Okay. Do you want to share a screen or just ask them?
Yes, but you should stop sharing anything, because otherwise it does. Okay. Can you see it?
Yeah, I can see it.
Okay. About the equilibrium in the sticky prices model without the nominal rigidity. So in the first part, here in the end, we say that in this last equation that the quantity produced by one firm is equal to the total demand.
Yeah.
But why should the quantity produced by only one firm be equal to the total demand?
So, okay,
so be the quantity of all firm equal to the total demand.
Yeah. So there's two ways to answer this question. First one is, you see, I guess I'm not reading your blue part here, but I guess you see that the price of any one firm is going to be the same as the price of every firm.
Yeah.
Okay. And then as far as the other one, we're a bit loose with notation here, because there's actually a continuum of firms, right? So each of these firms is very tiny. So really you should be multiplying both sides of that equation by like a little d index for the firm. So each firm is infinitesimal. They're each infinitely small. So like when you think about the y on the left-hand side, you want to think about that as like the share of output that goes to, one infinitesimally small firm. So if you're to divide output by an infinite number, then like it would, a little tiny bit would go to each firm, and that's the amount that each is producing. And if you actually look through sort of the logic, you can see in some places where I take a derivative, I'm being a bit loose with the notation, but that's essentially what's happening here. You could think about it as an average rather than the total.
Okay. And in monopolistic markets, the total demand should be thought of as the sum of the single demands of each firm, or as the average of all demands?
Yeah. So again, it's got the same thing, right? The same sort of observation. So I mean, I guess, let's see here. When you're talking about the aggregate demand function, that probably should be, you should think about that as the total. But it's a bit loose here because of the way that I've been a bit loose with notation.
Okay. Thank you. So here in the last question on the problem on sticky prices, I see that the book defines this variable pi, which is the log of this thing, with the C. So
Okay.
there is also this part. But here in the problem, I don't find the C. So I'm wondering why. Or why is it omitted? What's the assumption here?
Yeah, well, I guess if C were equal, I mean, if eta were equal to infinity, like as eta approaches infinity, then I guess that you would say that C is equal to 0. So maybe that's what they have in mind here. But wait a second. Let's see here. So yeah, so pi here, or wait, p star here is the choice of the firm, is that right? And then pi
Yes,
is
yes.
yeah,
Pi
okay.
is the price of a single firm, the log of price.
Yeah. But P star is the P star in not in the part from the book, so not 6.58, but in 6 point above there. Up, stop, down, down. Yeah, the yellow part that's highlighted there in yellow. That is P star here is the choice, right?
Yeah.
Yeah, I mean, I don't know, maybe it's either it's not important or they just assume that eta is approaching infinity. But if eta is approaching infinity, then there's nearly perfect competition. So, I mean, I don't know if did you try if you actually put C in there and then work through the problem, does it make any difference?
I should try.
I don't know if it, yeah, I suspect it won't make a difference. It might just make things more complicated. But yeah.
Thank you. And what are the weights in the exercises and the exam? Are there weights or?
No, there's no real specific weights. I mean, people have asked me about this in the past, so I don't like, you know, I grade according to the Danish sort of grading scheme. But if I were to say anything, the short answer and the in-depth sections are similar, and then the essays maybe got a little less weight. The essay is just applying something from class to a real world problem. So yeah, so you know, roughly, without pinning down an exact number, approximately the same weight for the first two sections, and then a little bit less on the essay.
Thank you.
Sure. So yeah, I'll have to get back to you about that one. I haven't looked at that mock exam question for a while. I'm sure there was some reason why I did it the way I did it. I seem to recall that there was some issue. Like I might have done it the way that it's done in the book first, with defining k as k divided by n, but then it created some issue, as I recall. This is now my memory going back a bit. And then I remember talking to a student about it and then changing it. So I'm sure there's some reason why I did it, but I can't remember exactly what it was.
Thanks.
Okay. Any other questions? So we're going to do something similar next week. Okay, so I'll solve the rest of the last year's final. And then again, I'll open up for questions about anything that you guys have about the course, different problems, whatever. So if you do have further questions, that would be a good time to bring them and ask them. So yeah. Okay, so if there's no more questions, then I think we'll end the class for today, and I'll see you guys next week. Okay, have a nice weekend.